For safety. This section of BS 7671 details the protective measures necessary to ensure the safety of persons, livestock, and property from hazards that may arise from the use of electricity. 4.1 Chapter 41. Protection against electric shock. Chapter 41 specifically addresses protection against electric shock, a critical aspect of electrical safety. It focuses on the application and coordination of requirements related to protection against electric shock, considering external influences. The chapter is based on BSEN 61140, which outlines essential requirements for protection against electric shock. 4.1.1 Explain the concepts of basic protection and fault protection. Chapter 41 relies on two key concepts. Basic protection. Basic protection safeguards against electric shock under fault-free conditions. It prevents contact with live parts of the electrical installation when no fault is present. In low-voltage installations, basic protection generally corresponds to protection against direct contact. Methods of achieving basic protection. Insulation of live parts. Covering live conductors with insulation that can withstand expected voltages. Barriers or enclosures. Placing live parts inside enclosures that provide a degree of protection of at least IP2X or IP4X. Obstacles. Using obstacles to prevent unintentional contact with live parts. Placing out of reach. Positioning live parts so they are not accessible. Fault protection. Fault protection safeguards against electric shock under single fault conditions. It protects against dangers that may arise from contact with exposed conductive parts during a fault. In low-voltage installations, fault protection generally corresponds to protection against indirect contact, mainly with regard to failure of basic insulation. Methods of achieving fault protection. Protective earthing and bonding. Connecting exposed conductive parts to earth to provide a low-impedance path for fault currents. Automatic disconnection of supply, ADS using protective devices, e.g., circuit breakers, fuses, and RCDs, to automatically disconnect the supply in the event of a fault. Double or reinforced insulation. Providing an additional layer of insulation so that a single fault will not cause an electric shock. Electrical separation. Providing safety by means of an isolating transformer. Limiting the magnitude of a current resulting from a fault, which can pass through a body, to a non-hazardous value. Limiting the duration of a current resulting from a fault, which can pass through a body, to a non-hazardous time period. Protective equipotential bonding is one of the important principles for safety in connection with fault protection. To comply with the regulations for protection against electric shock, electrical installations must incorporate both basic protection and fault protection. A protective measure or general protective measure has to have a combination of basic and fault protections. 4.1.2 describe the protective measures used to prevent electric shock, such as automatic disconnection of supply, ADS, double insulation, electrical separation, and SELV/PELV. To prevent electric shock, BS 7671 outlines several protective measures, each designed to provide both basic and fault protection. Automatic disconnection of supply, ADS. This is a primary protective measure that combines basic and fault protection. ADS relies on protective earthing and bonding to create a low-impedance fault path. In the event of a fault, a protective device, fuse, circuit breaker, or RCD, automatically disconnects the supply, limiting the duration of the shock. ADS involves earthing all accessible exposed conductive parts. Double or reinforced insulation. This protective measure provides safety by using equipment with double or reinforced insulation. It ensures that a single fault will not cause an electric shock, as there are two layers of insulation protecting against contact with live parts. Equipment with double or reinforced insulation is designated as Class 2. Electrical separation. Electrical separation involves isolating a circuit from earth and other circuits using an isolating transformer. This measure prevents electric shock by ensuring that a fault to earth will not create a dangerous current path. Electrical separation is typically used in specific locations, such as medical locations, or for supplying individual pieces of equipment. SELV, safety extra low voltage, /PLV, protective extra low voltage. SELV and PLV systems use extra-low voltage, not exceeding 50 VAC or 120 VDC, to reduce the risk of electric shock. SELV systems are separated from earth and other circuits, while PLV systems may have a connection to earth. These systems are commonly used in environments where there is an increased risk of electric shock, such as swimming pools or children's play areas. 4.1.3 discuss the methods of disconnection for TN and TT systems and the application of RCDs for additional protection. The method of disconnection and the application of RCDs, residual current devices, vary depending on the earthing system. TN systems, TNS and TNCS. In TN systems, ADS is achieved by ensuring a low-impedance earth fault loop. Overcurrent protective devices, circuit breakers and fuses, are used to disconnect the supply in the event of a fault. The disconnection times are specified in BS 7671 and depend on the voltage and the type of circuit. In TN systems, the neutral conductor need not be switched if certain conditions are met. TT systems. In TT systems, the installation has its own earth electrode, independent of the supply earthing arrangement. RCDs are the primary means of providing ADS in TT systems. RCDs detect earth fault currents and disconnect the supply if the current exceeds a specified threshold, e.g., 30 milliamperes. The disconnection times are generally faster than those achieved by overcurrent protective devices alone. RCDs for additional protection. RCDs provide additional protection against electric shock in both TN and TT systems. They are particularly effective in detecting earth fault currents that may not be high enough to trigger overcurrent protective devices. BS 7671 requires the use of RCDs for additional protection in various situations, such as for socket outlets and circuits supplying mobile equipment outdoors. For fire protection, RCDs with a rated residual current not exceeding 300 milliamperes are used. RCDs should be selected to limit the risk of unwanted tripping. These measures collectively ensure comprehensive protection against electric shock, with specific methods tailored to different earthing systems and installation requirements.